Welcome back everyone. In this video, we'll dive into the concept of system of equations. Whether you're a beginner or looking to sharpen your skills, I've got you covered. By the end of this video, you'll be solving system of equations like a pro. So let's jump right in. Before we tackle examples, let's make sure we understand the basics. A system of equations is a set of equations with multiple variables that have the same solution. These equations are typically linear and can be solved simultaneously to find the values of the variables. Let's begin with an easy example to warm up. Consider the following system of equations. Equation 1 is 2x plus y equals 10, and equation 2 is 3x minus 2y equals 4. To solve this system, we'll use the method of substitution. First, let's solve equation 1 for x. To do so, we will subtract y on both sides, which gives us 2x equals 10 minus y. We can then divide both sides by 2, and we get x is equal to 10 minus y divided by 2. Perfect. We can then substitute our x value into equation 2, where we get 3 times 10 minus y divided by 2 minus 2y is equal to 4. Simplifying this equation, we get 15 minus 3y minus 2y is equal to 4. We can then combine like terms, and we get 15 minus 5y is equal to 4. Afterwards, we can subtract 15 on both sides. We get negative 5y equal to negative 11. Divide both sides by negative 5, and we get y is equal to 11 fifths. Now that we have the value of y, let's plug it back into equation 1 to find x, where we get 2x plus 11 fifths equals 10. Now, let's subtract the fraction on both sides, where we get 2x equals 10 minus 11 fifths. We can then simplify the expression on the right side of the equation to yield 39 fifths, and divide that by 2 to isolate x. So we get 39 over 10. As you can see, we now have our solution to the system, in which x is equal to 39 tenths and y is equal to 11 fifths. Now that we're warmed up, let's move on to a medium level example. Consider the following system. Equation 1 is 3x plus 2y equals 14. Equation 2 is 5x minus 4y equals 7. This time, we'll use the method of elimination. Let's multiply equation 1 by 2 and equation 2 by 5 to eliminate the variable x. Simplifying this system yields 6x plus 4y is equal to 28, and 25x minus 20y equal to 35. Now, let's add these two equations together to eliminate y, which yields the single equation of 31x minus 16y is equal to 63. Then we can choose to isolate x in this equation, and doing so will require adding 16y to both sides. So we get 31x is equal to 63 plus 16y. Divide both sides by 31, and you get x equal to 63 plus 16y over 31. Now, let's substitute this value of x into equation 1 or 2 to find y. In our case, let's use equation 1. So we have 3 times 63 plus 16y divided by 31 plus 2y is equal to 14. Now I strongly encourage you guys to pause this video and solve for y yourself, so that at least you guys can still be engaged. But after you distribute the 3 into the fraction and solve for y, your final answer should be 2/3. Again, if you don't believe me, pause the video, run the math yourself. You're going to get 2/3 for y. Now, since we have y, we can substitute into equation 1 or 2 to find x. Let's substitute the value of y into equation 1. So in this case, we end up getting 3x plus 2 times 2/3 is equal to 14. After you distribute the 2, subtract, and divide, your final answer will come out to be x is equal to 28/3. And as you can see, you have a solution to the system of equations where y is 2/3 and x is 28/3. Once again, feel free to pause the video, work out the math, and if you get the right answer, congratulations. Okay everyone, now let's tackle a more challenging example to put our skills to the test. And I suggest we all buckle up for this one. So in this system of equations, we have the x, y, and z coordinates. And to solve this system, we'll use the method of either substitution or elimination. Let's start by eliminating a variable using the method of elimination. First, let's eliminate x by multiplying equation 1 by 2 and equation 2 by 4. Oh, whoops. There we go. As a result, we get 8x plus 6y minus 4z equals 20, and 8x minus 20y plus 12z equals negative 16. We'll then subtract equation 2 from equation 1. So we have 8x plus 6y minus 4z equals 20 minus 8x minus 20y plus 12z equals negative 16. As a result, this difference becomes 26y minus 16z equals 36. Perfect. Now, I hope you guys wrote down the system of equations. If you didn't, go back and record it, because in this next step, we are going to eliminate x again by multiplying equation 1 by 1 and equation 3 by 4. So here we have 4x plus 3y minus 2z equals 10. We're going to multiply equation 1 by 1, and we have equation 3, which is x plus y plus z equals 3. The whole equation will be multiplied by 4. After distributing 1 and 4 and simplifying both equations, we end up getting the value of, let's see here, 1 times this, 1 times that. We get 4x plus 3y minus 2z equals 10. 4x minus 4y minus 4z equals 12. We're going to subtract equation 1 from equation 2. So we get 4x plus, let's be plus 4y plus 4z equals 12 minus the equation of 4x plus 3y minus 2z equals 10. As a result, the difference becomes y plus 6z equals 2. Now we have a new system of equations. We have 26y minus 16z equals 36. Let's bring that down under. And we'll also grab this as our new system of equations. Perfect. Now we can solve for either y or z. In this case, I am going to multiply equation, I'm going to multiply the bottom equation by negative 26. As a result, we get negative 26y. 26 times negative 26 times 6 becomes negative 156z, which is equal to negative 52. And our top equation will remain as is, and you will notice that we are able to cancel our y variable, and we just multiply our respective terms. 156 plus 16 is 172, or negative 172z, and 36 minus 52 is negative 16. Therefore, z variable becomes 16 over 172. And if I am correct, I believe this ends up becoming 4 over 43. Yeah, that can be simplified. So now that we have our z variable, we can grab the value of z and plug into the bottom equation. So here we have y plus 6 times 4 over 43, which is equal to 2. This ends up becoming 24 over 43 equals 2. And then we can subtract the fraction on both sides. Okay. Now, let's see here. Two minus 24 over 43. That's approximately 1.442. Or if you want a precise answer, we can do, let's see here. We can actually make this a more precise answer. We can make the 2 in terms of 43. So we can do 86 divided by 43 minus 24 divided by 43, which ends up equaling 62 over 43. And perfect. We now know two solutions to this system of equations. We have y equals 62 over 43 and z as 4 over 43. We can grab this equation and plug into wherever we deem it necessary. So we'll grab our y and z value and plug it into this equation right here. So therefore, x plus 62 over 43 plus 4 over 43 is equal to 3, and therefore x plus 66 over 43 is equal to 3. You can subtract fractions on both sides, and we get 3 minus 66 over 43. And now, let's see, how can we turn 3 into a fraction? So we'll just grab 43, multiply it by 3, and we get 129 divided by 3 because it's equivalent, so we didn't really change anything, over 66 over 43, which becomes 63 over 43. And that is how you solve a system of equations for a problem like this one. Okay, congratulations, you and I have conquered system of equations from easy to hard examples. Always remember, practice makes perfect. Keep exploring and learning your skills, and soon you'll be a master at solving any system of equations. Don't forget to like, share, and subscribe for more math tutorials. Until next time, good luck everyone.